Good afternoon. So can you please let me know whether it is clear for you all? Is that clear? Can you all hear me?
Yes, madam.
Okay, thank you, Marsha. Okay, today is the last day of this lecture. Actually, majority of the chemometrics parts and the data analysis and the statistics we have discussed so far. So you remember that we discussed about the t-test and outlier, how to find outliers, and how to g-test, q-test, f-test, all the significant testing. And last week we discussed about some little bit advanced thing called ANOVA. Do you have any questions so far? I will prepare the tutorial, and I think I have not uploaded the last week lecture material also. Along with the today's lecture, I will upload the last week lecture material, and also by the end of this week, I'll upload the tutorial, and then I think we have to check with the faculty timetable. I think we will not be able to conduct online lectures after this week. I'm not sure about it. Please look your FOSMIS notification. Have you informed whether the lectures will be next week or not? So is Dean sir informed you about the lecture schedule? Is there any notification or notice in your FOSMIS? Okay, looks like no reply. I don't know. I don't know whether it's okay. Anyway, for this lecture, today is the last day, but we do have one tutorial. The tutorial is supposed to do on 14th of December, but I don't know whether the online lectures will be stopped from this week or not. If the online lecture series stopped by this week, then we will not be able to do tutorials online. But anyway, if that happens, we will do at least 1 or 2 hours. Let's discuss the tutorial whenever you guys come to the university. So anyway, I will post the tutorial in LMS. Then you can work on that and get ready with the answers. And what we can do, whenever either we can have an online meeting, or physically when you come to the university, we can meet and schedule one tutorial hour. So please check LMS, and most probably I'll upload that tutorial by Friday this week. Okay, and today let me share the screen for today's okay. I hope it's all of you can see my screen. So today we will discuss some, actually it is not advanced chemometric part, right? It is called as multivariate analysis. multivariate analysis. Before we go to the multivariate analysis, I would like to introduce few terms. And if we talk about the multivariate analysis, actually, it is difficult to teach multivariate analysis from 2 or 3 hours. The reason is you have to have some software installed, and there are lots of mathematical calculations undergoing. So therefore, at your level, I will not going to cover this multivariate analysis because it is little harder than the statistic that we taught so far. What my purpose is, I will give you an introduction about the multivariate analysis. So suppose if you do this statistic in any day, so you will have the basic and you will have the introduction or the basic background, you will know it. I will not going to do any question or any statistical calculation using the multivariate analysis. What I'm going to do, I will briefly explain what is known as this multivariate analysis. Before we move to the multivariate analysis, univariate analysis. That's the most important thing, and that's what we have done so far. So univariate analysis. Univariate. The name also implies something. Uni, that means single. So variate means variable. So in the univariate data, if we talk about the univariate data, it has only one variable. Right? There are only one variable in univariate data. So that is the simplest form of the analysis. The reason is, in the univariate analysis, since it is dealing with one type of data or one quantity, so it is the easiest thing to deal with, or it is the easiest thing to analyze. An example has been given here. If you take the heights of 7 students in a class, so consider we are taking height of 7 students in a class. That is a data. Actually, that is a data sample, right? So heights are data samples, and the number of students is 7. There are 7 students. But here, how many variables? 1. Height is the only variable. The number of students is changing. That's the frequency, or that's the amount of data that we are collecting. Only variable here is the height. So that is the only thing which is changing. And this height is not dealing with any cause or relationship. So if we take, suppose in the 7 students, there are 4 female students and 3 male students. This height is, there's no any relationship between the gender or the height, or there's no any let's say, there's no any relationship or the cause of the height with anything. Therefore, the only variable is the height. So because of that, we call this set of data as univariate data. That means it has only one variable. And the next thing is bivariate data. Univariate, bivariate. Bi means 2. Variate means variables. So in the bivariate data set, there are 2 variables. So as the name implies, it involves 2 different variables. And here the analysis deals with causes and relationship. So in bivariate data analysis, so there are some relationship between data sets, and analysis is done to find out the relationship among the two variables. So when we do the analysis is doing to find out the relationship between these two variables. So look at the example given. For example, this table has been tabulated. It contains the temperature and ice cream sale in summer. We know during the summer it's a hot season, therefore people are eating more and more ice creams. So look at the relationship. When the temperature is increasing, the number of ice cream sales also has been increased. So these are two data sets. Temperature and ice cream sales are two different data sets, but even though these are two different data sets, these two has a relationship. There is a correlation. When the temperature is increasing, the ice cream sales increase. Now we can make conclusion also. Suppose the temperature is 55. Now the temperature has been further increased and the ice cream sale will be more. So we can predict some things also based on the two data sets, right? Okay, this is the description. Here the temperature and ice cream sales are two variables, and you saw that the temperature and the sales are directly proportional to each other. So that means these two are related to each other. So there's a relationship. In the bivariate data, we told that the data should have some cause or some relationship. So there's a relationship between the temperature and ice cream sale. And the bivariate data analysis involves comparisons, relationships, causes, and explanation. So the same thing, it's repeating same thing. So this bivariate data analysis, it involves comparison. We can compare the two sets of data, and there is a relationship, and there are some causes and effects. And also we can explain these things, the two sets of variables. And suppose we are plotting a graph. If we plot a graph with two axes, x and y, we can include these two variables to two different axes. So either we can, let's say we are putting the temperature into x-axis, then we can plot when the temperature changes, how the ice cream sales change. So the temperature can be plotted in the x-axis and the ice cream sale will be in the y-axis. So if we plot these two variables in a graph, then we will be able to get a line graph. Okay, so that is the bivariate. So univariate means only one variable. Bivariate has two variables which has some relationship between each other. Then what about the multivariate data? So multivariate has multiple variables. So multiple variable means at least this multivariate data should have 3 or more. Because if there are 2 variables, we call it as bivariate. If there are 3 variables, normally we do not call it as trivariate. We call it as multivariate. If there are three or more different data sets or three or more different variables, we refer it as multivariate data. So today we will discuss this multivariate data. So how we can analyze this multivariate data and what are the importance of this multivariate data and how we can come to conclusions using multivariate data. It is difficult, right? Because if there are two variables, we can either plot a graph and see the relationship. Suppose we have 7 variables. Okay, now we have 7 types of variables. They are related to each other. But how can we compare them? Do we have 7 dimensions to plot data? No, we don't. So there should be some way, because the day-to-day examples, if we are going to do some analysis in our day-to-day life, most of the time we will not find the univariate or bivariate data. Instead of univariate or bivariate, we will find multivariate data. So therefore it is really important to see how we can analyze this multivariate data. Okay, before we discuss that, I would like to explain these 2 terminologies, because this will be used in the statistics most often. So statistics can be divided into 2 types. One is descriptive and the second one is inferential statistics. Right? The descriptive statistics means the analysis of data helps to describe, show or summarize data in a meaningful way such that patterns might emerge from the data. So in the descriptive statistic, we will analyze data. Here we can show or summarize the data in a meaningful way. Right? So we have a data set. From this set of data, we are summarizing the data. For example, we have 7 measurements and we will take the mean of the 7 measurements. So that is the descriptive statistic. If we take a mean of those 7 set of data, that is kind of summarizing. Instead of telling all the replication, all the 7 replications, we can tell a mean, we can find or we can calculate the mean and we can show or report that data. So that statistic we call descriptive statistic. And this descriptive statistic does not allow to make conclusions beyond the data. So we cannot make any conclusion. When we take the mean of a set of data, we simply say the mean. But we cannot tell whether it is correct or wrong. We just summarize the data. There's no way to make any conclusion. We cannot tell whether it is an outlier, whether it is correct, or whether we should keep this data or whether we should remove this data. No, we cannot tell anything. We can just summarize and show. But in contrast to descriptive data, when we talk about the inferential data, this inferential statistics, it helps to make predictions or inferences about a population from observations and analysis of a sample. So this inferential statistics helps to make predictions. So we can predict about the population. We can make some conclusions about the population by looking at this inferential data. For example, let's say we are in the first example I told you that there are 7 measurements and we are taking the mean, that is descriptive statistic. And suppose we are doing t-test for that 7 measurements. And we will tell whether there is a significant difference between mean or anything using t-statistic. Or suppose we are doing some G statistics to find an outlier or anything like that. Then we are going beyond the summarizing. We are not just summarizing the data, or we are not just showing the data. We are trying to make some conclusion based on this data set. Then this type of statistic we call as inferential statistic. I hope it's clear because I couldn't summarize this one earlier. That's why I include it here. So, for example, this is the example that we discussed already. So, in the univariate analysis means we have only one variable. In a univariate analysis, it can be divided into 2: descriptive statistic and inferential statistics. Under descriptive statistic, these are the examples of the descriptive statistic. So, mean, median, mode. That measures the central tendency. And also the range, confidence interval, variance, and standard deviation. Those are also summarize the data set. So, all these things can be listed under descriptive statistics. And as we discussed earlier, inferential statistic, all the C-test, we have not discussed C-test, and T-test, chi-square test, F-test, Q-test, G-test, any of these tests can be listed under inferential statistics because those tests helps to make conclusions about the population. So that is the difference between the two statistics, right? That part actually I included here because I couldn't include it. I couldn't mention to you in the previous lectures. And so look at the statement here. Important decisions and products we use every day are often based on univariate analysis that does not necessarily tell the full story or might not even be accurate. Right? So, by using a single variable, actually we make some decisions in our day-to-day life. But simply by looking at that variable, maybe there are some other variables or factors affecting to some changes. But when we make decisions, we may not consider those important variables also. Those important variables might be neglected. So if those important variables are neglected, we cannot tell the full story or we cannot tell the correct story. Right? So therefore, whenever we make some conclusion about the population, we always have to look further and we always should go beyond the things that we see, and we have to do some multivariate analysis other than the univariate analysis. Okay. All right. Then let's move to multivariate analysis. Hereafter, in certain places, I will abbreviate as MVA. So if you see MVA in my upcoming slide, that means the multivariate analysis. So as I told you earlier, the real world problems are multifunctional. So multifactorial. When multifactorial means it has several factors. Most of the cases, the instrumental data that we get has different types of variable. So either the temperature might be different, or the concentration, or the number of scans, whatever the things can be different. So therefore, there we have to analyze the data sets which have more than one variable. Multifactorial problems need multivariate mathematics, including regression, to identify, extract, compress, and exploit the underlying structure in data. So using this multifactorial data, using this data set, we have to have some multivariate mathematics. We have to do some multivariate mathematics. Those include regression to identify. And when we do this analysis, the multivariate analysis, first we have to identify the variables, and we have to extract variables and compress. And the compress means using two types of variables, we have to reduce it to one type. So that has to be done using different techniques. We will go through those techniques later. So there should be a way to identify, extract, compress, and exploit the underlying structure in data. Right? And this multivariate analysis techniques allow more than two variables to be analyzed at once, including multivariate regression. So it should have more than two variables. Here, multivariate regression. Also, that is the one thing that that the NVA techniques, one of the NVA techniques. And multivariate analysis offers overview of complex problem by finding the latent variables that give simple model from complex system. So when there are a lot of variables, it is a complex system. It is not a simple system. When we do the analysis using different tools, we make this complex system into simple model. We will use some tools, maybe most of the time some software. So using the software, that is the easiest way. We can do it manually, but there are lots of softwares to do this multivariate analysis. We make the complex system to a simple model. We transfer the complex system to a simple model using different softwares. And interpretation of relationship between samples and variables, quality structure activity relationship, we call it as QSAR, qualitative structure activity relationship. Then we make this complex system into a simple model, then interpret the relationship between the samples and variables. Right? So this multivariate analysis has been used to, that is the, in conclusion, what is the conclusion in this slide is, we can use this MVA analysis or multivariate analysis just to make the complex problem just to transfer the complex problem into a simple model. That is the what we are doing in this multivariate analysis. I hope it's clear. And if you have any question, please leave me a message. Right? Okay. Then let's go to and see what are the types of data that can be used for the multivariate analysis. So this is an example. So by looking at this example, you will get an idea about which type of data that we can analyze using this multivariate analysis. The first one is spectral or chromatographic or image data. The spectral, chromatographic or image data can be analyzed using this multivariate analysis. The reason is in the spectral analysis also there are lots of variables, same as the chromatography and the imaging. For example, we can use IR data, infrared, Raman data, NMR data, XRD means X-ray diffraction data, fluorescence or excitation emission matrix, MRI, gas chromatography, HPLC, any of these data, any of the spectrum that we are obtaining from these instruments, we can analyze using this multivariate analysis technique. Right? That is the one type of data that we can be used. And another type is the process data. So that means some raw data, raw material data, some process variables, and inventory data. There are lots of data. If we talk about the inventory data, lots of data with lots of variables. So those things also can be analyzed using MVA. And sensory data. So most of the, give me a second. Okay, sorry about that. Let's go back. I'm sorry. Okay, here. The sensory data. So the instrumental data are some instrumental sensory data are available in some instruments. So those data also can be analyzed this MBA techniques. And product data, properties and price of buyer preferences and demographic. So those are some product properties and prices. Those type of data also can be analyzed. These are some examples. Sorry, these are some examples of the types of data. So you will get an idea. So you know why we need to do the MVA and which type of data we can analyze using MVA. By looking at this slide, you can tell that any type of data we can analyze using this technique. So whatever the data set, and the number of data sets, whatever the type of data, but just looking at this, we can say we can analyze any type of data which has more than one variable using MVA technique, right? Okay, then where do we use MVA? So why we use MVA? At what time? At which type of data we can use MVA we discussed, and then let's see where. So we discussed earlier also, this is used to generate simple model for a complex system. So we are generating a simple model for a complex system with using this. And the first thing that where we can use this MVA technique is to design of experiment. When we design the experiment, we can use this for formulation, product and process development. So that's one place. And also for optimization also, we can use this technique, process improvement and capability studies. and the process monitoring, we can use that. And analysis or exploration of some qualitative data exploration and quantitative risk analysis. So for those analysis, we can use this MVA. And quantitative calibration. So for the calibration also we can use, for example, when we do the analytical methods, when we do some spectroscopic analysis, we can use this MVA technique for the quantitative calibration. And process control. So in some process control means some model predictive control modeling and predictive analytics. So those are not actually, those are the examples, but no need to worry about that too much because it is not that much relevant to our purpose. Among all these things, the quantitative calibration, analysis, optimization, and design of experiment, those are the main thing that we are interested in, right? Because as an analytical chemist, those are the things we are interested in using this MVA technique. All right. Now let's move to MVA tools and purposes. What are the tools that is available, and what are the purpose of those tools? So I told in the previous slide also, we can use this MVA to design an experiment. So this can be used in experimental design. When we use this in experimental design, we can design an efficient experiment and we can analyze some effects, and also we can bring focus on valuable information. And the purpose is to find a significant effect, and by doing this we can reduce time and cost of experiment. And the exploratory data analysis. So principal component analysis, cluster analysis, MCR means multivariate curve resolution, multivariate curve resolution. So for this exploratory data analysis, we can use these MVA tools. So when we use this principal component, actually this principal component analysis, cluster analysis we can talk like several hours in these under these topics, but as I told you earlier, I will not go into lot of details. I will not go into depth with these things. I will just give you an introduction. So whenever you hear this thing, you will know, okay, these type of things are available, right? So I will not cover lots of things under this PCA or cluster analysis. So the exploratory data analysis, under the exploratory data analysis, we can measure the relationship within one block of variables, and we can map samples. There are some mapping techniques available, and here also we can group sets of data and we can generate patterns and find outliers, and we maximize the insight into the data set. So when there are a data set with lots of variables, we can give a maximum insight to that particular data set. So the purpose there is to describe quality and structure. So by an exploratory data analysis, we can describe the quality and the structure of that particular data. And also we can use this to classification and discrimination. What does that mean? So suppose we have here X is the set of data, that is the pool, and then we can classify it into A and B. So suppose in the school, there are different sets. And then we classify that into individual sets which has same characteristics. So for example, in the X, there's a subset called A. So we put all the things which is relevant to A under this subset. And the things which are relevant to B, we can list them, or we can separate, or we can classify it under B. So that is another advantage, or that is another activity of the MVA tools. And the purpose is to classify. Simple, classify samples into groups. We can classify. And another thing is the regression methods. So those things, we can make lots of conclusions about the set of data using this regression method. Here, lots of mathematics has been used. So MLR is for multiple linear regression, and PCR is the principal component regression, and PLSR is the partial least square regression. So using this regression method, we can make a relationship between two blocks of variables. For example, X and Y, there are two blocks of variable. We can bring them into a single model. We can put these two types of data into a one model. And the purpose here is to relate measurement with the reference, and it's kind of indirect measurement. That is not a direct measurement. It's kind of indirect measurement. So we relate the two types of measurements each other and put them into a single model. Right? So that is the those are the tools and purposes of this MVA methods. So you know, there are lots of advantages and lots of tools here. The listed things, the listed thing in the last two slides are, we can tell those are the advantages of this MVA technique. Right? Okay, then let's move to types of analysis. And what are the types of analysis we can do? This is the one of the most important thing. And even though we call as the multivariate analysis, there are several types we can use. So that's why I I told you at the very beginning, this is a huge subject. So if we learn this correctly, we have to spend lots of hours under this title. Okay. So what are the types of analysis? Multivariate analysis of variance. You know the variance, sigma square, right? So multivariate, the abbreviation has been shown in these brackets. Multivariate analysis of variance. This extends the ANOVA to cover cases where there is more than one dependent variables to be analyzed simultaneously. So this is kind of extension to the ANOVA. We learned that last week. So the ANOVA we already discussed how to analyze using the ANOVA technique. This MANOVA, we can abbreviate this as MANOVA. So multivariate analysis of variance. It's a kind of extension to the ANOVA. So here in the ANOVA, it does not have more variables. In here, it has more than one dependent variables. So all these variables we have to analyze at the same time. Right? And another type is multivariate regression. So that one determines a formula that can describe how elements in a vector of variables respond simultaneously to changes in others. So I think the vectors, all these things comes under mathematics. So for me also, I am also not that much familiar with this, those in-depth mathematics. Therefore, I just wrote the simple explanation here, right? So here I want to show you the available types like the multivariate analysis of variant, multivariate regression, and the principal component analysis. In chemistry, this is the most widely used technique, PCA or principal component analysis. Here, it creates a new set of orthogonal variables that contain the same information as the original set. So, in the principal component analysis, it takes variables which have same or similar type of information, and then we put these similar or same information into one original set, into one set. And it rotates the axis of variation to give a new set of orthogonal axes, ordered so that they summarize decreasing proportions of the variation. I will describe this in a simple way. Suppose we have different variables, and we are combining the variables with similar type. We combine the similar things, and now from the original variables, now we can reduce the number of variables into smaller number. Suppose if there are 3 variables with same type or with similarity, if there are 3 variables with similarity, now we combine these 3 together, and after combining these 3, we make a single variable. Then we can reduce the number of variations. So that is what is happening in the principal component analysis. And then factor analysis. So it is also similar to principal component analysis, but it allows the user to extract a specified number of synthetic variables. So here also fewer number of variables, and the unexplained variation keep it as error. And canonical correlation analysis. So it is a linear relationship among 2 sets of variables. Right? That is the generalized version of bivariate correlation. So in bivariate also, I told you that these 2 types of variables we can put it into x and y axis, and similar to that, in this canonical correlation analysis, we can take the 2 sets of variables and make a generalized version of the 2 sets of variables. Right? Redundancy analysis is also similar to the canonical correlation analysis, but here it allows the user to derive a specified number of synthetic variables. I will not go through that one also. Correspondence analysis finds a set of synthetic variables. It's also summarized the original set. The model assumes chi-squared dissimilarities among the records. So the chi-squared test used in that one. And here, canonical correspondence analysis, it summarizes joint variations in 2 sets of variables. So Another type is multidimensional scaling and discriminant analysis. There are lots again. Linear discriminant analysis, clustering system. The clustering system also little bit has similarity with principal component, but it's not that similar. The clustering also we are using in the chemistry. We use that one also, the clustering. And recursive partitioning, artificial neural network, statistical graphics, simultaneous equation models, the statistical graphics. So we can have some tours, the contour one, and coordinate plots and scatter plot matrices. That one also we use in chemistry most of the time when we do the analysis. And vector autoregression, principal response curves. Maybe those who are doing stats and mathematics, if you are doing statistics and mathematics, you will have more familiarity with these terminologies, right? Okay, those are the types of the analysis that we can perform. And here I have listed the software and tools. So I told you this multivariate analysis, it is highly time consuming if we are going to do this manually. So yeah, not only the time consuming, we will not be able to get most accurate result. Most of the time for this analysis, software has been used. This, the fifth one, the unscrambler. That is one of the most frequently used software for this multivariate analysis, the unscrambler. And MATLAB also most widely using in the chemistry field, because unscrambler and the MATLAB, those two are used widely when we do some chemical analysis. Okay, so that's the summary that I want to give you in this multivariate analysis, because I will not going to do any calculation, or I will not going to use any of the software, and I just want to give you a brief overview about this, because you should know, okay, we have this type of thing also, we have this type of analysis also, so you should be aware about that. That's why I give you an introduction about this. Okay, any question? Because I think you can go through these slides. So this is not that, because I just give some theoretical things, not any calculation. So it is not that difficult, because you can just read it. And even from the previous lecture, do you have any question? Because I think I will not going to teach any new thing today, but I was thinking, if you have any question, I can refresh some previous materials if you need. And I advise you to please go through that book, the Millers and Miller, because the lecture material I took from that book, and it has lots of detail. There's a separate chapter for the multivariate analysis also. The last chapter is for the multivariate analysis, but I will not cover that one. But if you are interested in, you can go through and read that one also. But for this other significant test, I highly recommend you to go through all the things in the books, and there are lots of questions also. You can go through these questions, and that will be more helpful for you to understand how to do the calculations. And another thing, several students asked me about the past papers. Several times, some students asked me about whether I can upload the past papers, but what I told you, I will ask Dr. Keith about that. But when I talked to him, this is the new course unit. So this course has not been offered earlier. Therefore, CHE 3122 course, there are no any past papers available for this particular course unit. So what you can do, you can practice the tutorial that I'm providing. So it will be more than enough for you. Just go through the tutorial and practice the tutorial. So you will, if you get familiar with the tutorial, it will not be a problem. So you will get similar types of questions in your exam. And also go through the questions in the textbook which is recommended, and also if you can find any other statistical book, so you can go through it, and there are lots of questions you can find it. So the best thing is to practice. So practice the problem. So whenever you practice problem, it will be easy. The significant tests that we discussed were not that difficult. So you simply need to get the practice. Only thing you need to know, whenever you get a question, which type of test that I should apply for that particular question. So list down the test and think about the incident, or think about where I can apply this test. That's the only thing you should know. Then the same thing you have to do for all the tests. First thing, we have to have a null hypothesis, and then we are going to correct that null hypothesis. And if you have to compare that the calculator. You can compare. The table will be given. If it is a t-test, t-table will be given. If it is a q-test, q-table will be given. So the calculated value you have to compare with the value given in the table. The value given in the table is called as the critical value. If the calculated value is less than the critical value, you keep the null hypothesis. If the calculated value is more than the critical value, we reject the null hypothesis. Simply, it is so simple. Only few steps. All the times you have to follow those steps. But the thing is, you should understand which test I have to apply for this particular question. That's the thing you should understand. Right? Okay, so looks like no question because I have not get any question. And since that's all we have to cover, I will stop for today, and please check your LMS. I will upload the tutorial end of this week. Go through the tutorial, and if you have any question, not if you have any question, and you should work on the tutorial, and if you have a question, you can discuss with your friends, and also email me. I think I gave you my email address, and If you don't have it, it should be in the very first lecture material, in the very first slide in the first lecture material. So you can email me. So I will help you with the tutorial. And if the online lecture series continues even the next week and so, only if it continues, I will take a tutorial hour on Monday 14th Monday from 2 to 3. So 14th Monday from 2 to 3, I will take that hour if the online lectures continues, and you can keep check on the LMS. If I am taking the tutorial, I will put an announcement in the in LMS also. So by that time, so you have 1 week, you can finish the tutorial and work on that. And 14th, we will discuss if the online lectures are continuous. If not, let's find a time once you guys come to the university, and let's do the tutorial. Let's discuss the tutorial. But I'm telling you, I will take only 1 hour. I'm not going to work on the all questions. What I will do, you have to work on the all questions and you have to come up with the answer. And if you have any question which you do not understand, then I will help you how to solve that question. Okay then. I have lecture recordings to the LMS. Yeah, one of you has asked me, can I upload lecture recordings to the LMS? Actually, I tried, but the size is too big to upload. I don't know, maybe there's one option. Maybe we can create a Google Classroom. So then I will be able to share this lecture material, the recordings in the LMS. I will try to upload. I will check whether I can upload it into Google Classroom. If it is possible, then I will upload it into Google Classroom. But to the LMS, I tried to upload, but those are too big to be uploaded. So that's not possible. And another one asked when the university starts. Still, I don't know, but most probably will start soon. Dean sir will put you note regarding that and when it will start. Still, I am not aware because still some discussions going on, and hopefully pretty soon the university will start. Any other question? Okay, looks like no other question. So then, okay, one more. One asks when the university start, is it start for the exams directly? I'm not sure, I cannot tell you at the moment all the things. You will be informed earlier by Dean's office. So please, I think you all fixed to the first notice, and please be aware about the first notice. I don't know when it starts or whether it's start directly, exams will directly start. I don't know anything, but you will be informed early by Dean's office. Okay. Okay. So if you don't have any other question, no. Okay then. Let's stop this lecture series. And again, I'm telling you, if you have any question, please email me. And okay, good luck with your exams. And also do the tutorials also.